The objective of this lesson is to explain how important variable encoding is to memory size. So this will be a huge lesson, especially in terms of vocab. And after our last lesson where you got to play around with some circuits, now we're going to just kind of bring it back with lots of vocabulary. So bear with me. If I'm saying any words that you don't know what they mean, go ahead and look them up. Today we're learning about memory size and how programmers and users can affect this. So remember, only 4 things are ever happening in a computer. You're getting an input, processing is occurring, then storage, and then output. And that happens over and over and over. What we've not started is adding binary yet. That's not very complicated. In progress is just our knowledge of how Boolean logic works, okay? And then completed, at least we know what a Boolean is. So let me start off with this student testimony. I think it's really powerful in terms of why we do repetition in class. So this student says, "It's funny how repetition and actually doing the work leads to all of a sudden making sense to me. I can't explain it. I don't have a sense of growing understanding. I have confusion, repetition, and suddenly a sense of understanding. It's not coming through watching or reading, though. It comes from replicating what I've watched several times. This has happened repeatedly for me in this class. I start the week with a sense of accomplishment, well-being, peace of mind, and confidence from the victory over last week's homework. I am then submerged in doubt, confusion, and terror." So why not be melodramatic, they say. "Suddenly there is a working epiphany, and I have victory again." So they're kind of talking about how their week goes. You know, I start off with reviews on Monday, and in the week on the brand newest innovations. So if you're needing some motivation right now, just know that you're not alone. These are the types of things that students are saying in their International Bachelorette reflection questions, okay? All right, a real fun website we'll use today is called Pingdom. And if you Google Pingdom, that's not the best way to get to where we're going, though you can learn quite a bit about this company from their homepage, right? But I need you to go to tools.pingdom.com. All right, that URL is going to be right here as well. So to start off class, since we're talking about memory size, and I want you to choose a website, any that's school appropriate, and find out the following information about that website. I want you to find out the page size, the size of the scripts, and the size of the CSS, since we just finished that in the last unit. And don't forget to add the units, you know, megabyte or kilobyte or whatever. So from tools.pingdom.com, you will just enter the URL. I suggest you search from the San Jose servers that they have. And from those San Jose servers, you'll find information like CNN.com here. It has a page size of 3.1 megabytes. And then if you scroll down, you'll see other information like this. There are 1.8 megabytes of scripting in there, JavaScript, of course. There's 166 kilobytes of CSS. But this right here is the minimum that I want you to pull out of a random web page. That way you can start thinking about all the variety that is out there. So you'll see other students' answers popping up with different websites that they chose. So it's an interesting thing to kind of compare and contrast. And then you can just make the assumption from there. Why is variable length encoding important? Why is compression important? It doesn't take a genius to realize that even though we're moving at the speed of light, well, technically 80% of the speed of light, even though those ones and zeros are traveling almost at the speed of light through the wires, they're still going to take time to get to you. So websites and even streaming companies like Netflix, they do their best to find out the correct encoding to use to get the speediest transfer that they can. When you save something locally, seeing how we've talked about this before, there is like such a small time delay from you clicking on something locally and then it popping up on your screen. But when you go to a website or you're trying to watch a movie or a video snippet, it may take quite a long time. And that frustrates people and makes people not want to use those services. So speed is not only good for bragging rights as a company, but it could actually mean dollars. So let's talk about this. Encoding theory, a variable length code is a code which maps source symbols to a variable number of bits. And if you remember, we've talked about this using the example of Hawaii. Things that repeat should be the lowest amount of bits, and things that repeat very rarely, we can assign a larger bit value to those things. Now, this is still a form of lossless data compression. Remember, lossy or lousy compression is totally fine with pictures because our eyes can't detect the difference in colors very well. So all those differences in colors do not need to be transmitted over the wire. So your think, write, share, pretty simple one right here, just to make sure you're still with me. What does lossless mean in this context? So I've mentioned encoding before, and ASCII is the way that letters are encoded in binary format, okay? So an ASCII table provides a means for a byte to represent a number. So what I mean when I say binary represents a letter, when the computer gets, half a volt, full volt, half, and a full one, this binary 4-bit, aka 1 byte of information, is the decimal number 65. I only put that there so you can think in your mind that anytime the computer gets the number 65, it knows to display the letter A on your screen. And if you think about it, all of this encoding here, each one will need to have a unique value, and that includes uppercase and lowercase letters. So each thing that is encoded must have a unique number, and that even goes for numbers. The number 5 has an ASCII encoding to it, and other symbols that you can see on your keyboard right there, they all are encoded with a special value. If you're curious to learn about these values, 1 through 31 is control codes, 32 to 64 are symbols, then we'll hit our uppercase numbers first, then some more symbols, then lowercase, more symbols, commands like delete, and then we'll have some international symbols in there as well, as in the pound sign or the euro sign for those foreign currencies. Here's another way to look at the ASCII table. If you take my computer science class next year, we'll learn about hexadecimal values. That's pretty fun. But in the meantime, just know that when the computer gets the binary number for 64, it shows the @ sign. If the computer gets the number 110, it's going to show a lowercase n. And there is a slight difference between processor or virtual storage and disk storage. So oh man, this is rough to wrap your mind around. Let me say no more about this and just let you look at these two tables here. And for your think, write, share, just tell me what you notice in terms of the difference between the two. Absolute extra credit if you could tell me why there is a difference between those two. So let's move on. Using varying length sequences of digits to encode letters of the alphabet can get us into trouble. Fixed length codes are indeed very important. As we have seen, ASCII, the most widely used code for representing text in computer sentence systems, is a fixed length code. But don't you worry, text is not very large in terms of disk storage. And so I answered the think, write, share inside this paragraph. I'm going to say it to you now. What is the opposite of variable length code? Coding? Well, it's going to be a fixed length code. So one more visual to hammer home what I'm talking about. So this is an example of a variable length encoding using letters. You can have the C be represented in 4 bits, E in 4 bits, G has 6 bits, and A only has 1 bit. So here I'm asking you to use this figure to explain how the Huffman variable encoding saves memory. If you need a sentence starter, you could say based on the data stream. So here is the data stream. And if you look up here, this example encoding table is really helpful because there's a column here called probability. So essentially, to answer this think, write, share correctly, you need to stare at the probability right here. All right, now, and if you get even slightly stuck on this, raise your hand, ask for my help. That's what I'm here for. And before I wrap up the lesson, I just want to say there is a big difference between storage and transmission, all right? A codec is worth your time to understand and know about, but it's a little bit much for this lesson, so I'll just quickly go over it. A codec is a device or program that compresses data to enable faster transmission and decompresses the received data. So this is essentially what Netflix uses, and they've changed their codecs that they use. But essentially, once you have that downloaded or once you're on their website, that data of how to decompress is already there. So the actual transmission is very small. If you just look at this one example, the bit depth of 12 bits leads to 4,000 possible colors. That's not typical, okay? So they do some fancy math, and that's where math comes into play with programming and computer science in general. I won't say much more about that though, because our focus today was simply on the importance of variable length encoding to memory size. Remember, you have a finite amount of memory on your computer, and you have a finite amount of time that you're willing to wait for a web page to be rendered. If you want to learn more about this, I suggest the YouTube video called The World Wide Web Sucks by Brian Lunduke. He is a great YouTuber. We're pretty much done here, so pick an IB question to answer. So here's your DOL. I want you to use 2 examples to explain how significant variable length encoding is or is not. So you can either take the opposite approach and try to convince me it's not significant at all. As long as you're using information from the lesson, you're going to be good. And then I just have a question: are 5 megabyte websites too big? Why or why not? And if you do need an exemplary example, here's kind of what I'm looking for number 1. I'll let you go ahead and just pause and read it if that's what you need.